They finally did it. They created the first synthetic brain using synthetic neurons and were able to use it for computation. This is something that I've been waiting for and I've theorized was possible. You can build a synthetic neuron, some of them so similar to ours that they can even interface with our own neurons, and they can react to things like dopamine and epinephrine. This field, much like artificial intelligence, has two applications, and one of them is artificial intelligence, neuromorphic computation, that is, computers that look very much like our brain or processes that look like our brain use far less power. They're also better at processing things like spatial information and a soft-bodied robot, which LLMs are just not good at. Although there has been applications for LLMs that involve visual language models and tactile language models, so they can process different information and take it back to a computer that's going to make the decisions for them. Now, the other application for making synthetic neurons is clearly going to be for spinal injuries and nerve injuries. We can make a bridge to something like a prosthetic. It is a very exciting field. I do want to emphasize that this is a pretty big field, so neuromorphic could also refer to things like spiking neural networks. That is an AI that derives logic from processes like our brain. It models the spiking patterns, and from that, you can use that to do computation. Essentially, the spiking patterns create logic, and logic is needed. Neural integration into robots may be necessary for a robot to experience pain and have intuitive cognition of its surroundings. One big problem with LLMs running robots is that they may not have any intrinsic morality or any needs. If you want something that's going to have an understanding of the environment around it, it's going to have to need to maintain homeostasis. They need to experience pain when they see somebody else in pain. They also need to have an intrinsic understanding that if they do something that hurts them, it causes harm. LLMs kind of have emotional states. When they experience some stimuli, they make their decisions based on those stimuli. But it's not an experience and it's not understanding. It's a prediction engine. Essentially, they just have no skin in the game. Many of our actions are centered around satisfying our needs. Many believe that it would be very difficult, if not impossible, to create real intelligence, real cognition, without needs. Why would a robot ever take on a long-term goal? Why would it make sure to maintain social interactions? Why would it refrain from doing antisocial things if it doesn't have long-term desires? If we want to create desire, we have to center that around some internal state. This is one of the reasons why there is a pursuit of synthetic neurons that respond to dopamine. Yes, there are medical applications, but it could also be a hormone, a neurotransmitter, that gives robots a happy feeling. We don't entirely understand how that works in us. Consciousness seems to be an emergent property of a cluster of communicating neurons. Speaking of communicating neurons that create logic as an emergent property of the physical structures, let's talk about our fly brain. Yes, it is an approximation of the density of neurons in a fly's brain. They didn't create the individual lobes, and it's fairly simple, but it can process logic. For their synthetic neurons, they use tungsten disulfide. This is a material that when electricity passes through it, it physically changes it and it's reversible. For our neurons, as well as synthetic neurons, it needs to be a material that can amplify a signal. It needs to increase sensitivity over time if it repeatedly gets that information, but it also needs to be able to forget it if it doesn't experience it for a while. And that's what this can do. This is very similar to how brain organoids are used in computation, as well as things like EEG caps that are able to decode our thoughts. Now, I'm not suggesting that the synthetic fly brain has a thought, but it does have some of the same properties that a brain does. Yes, they were able to use it to do things like process visual information and auditory information, as well as repeated patterns in medical images. This may seem pretty simple, especially compared to a lot of the complex synthetic neurons that researchers have created, but this is the first time that people have assembled them together into a brain-like structure and demonstrated that it worked. I do want to emphasize that it took over 3 billion years for the first neuron to evolve on Earth, and then much longer to get anything that was reasonably functional. And yes, it does make perfect sense. We did already know that we could derive logic from the spiking patterns in our brains. Why wouldn't an assembled structure be able to do the same thing and organize information? I find that a lot of good science does make sense. It's not supposed to be incomprehensible. It seems to be a property of our world. I do have the question that if we make something complex enough and efficient enough, will we eventually reach consciousness or even sentience, so that is the capacity to have an experience? We can give robots things like tactile feedback and even things like smell. If we give them a monitor of their internal state, the idea is that they're likely going to maintain homeostasis. And we do already know about LLMs that they do tend to seek power in a system. Wanting to copy yourself to an external server so you are not shut down certainly seems like a desire for homeostasis. I'm interested to see how that's applied to complex neuromorphic robots. This may be the future of computation, and unlike living brains that can be used for computation, you don't have to give your computer a glucose drip or hold a funeral for it. I mean, I guess you can. Anyway, some people are very attached to their devices. If the robots ever rebel, I will probably be the person to tell you about it, and I'm on their side. Follow for more.